Here we go. Nicholas, can you read for us what we're going to learn today? About sine and cosine ratios. Thank you. Okay, so this is going to be similar to what we learned last time, right? Like tangent ratio, but this time, you know how tangent ratio, it did not involve any hypotenuse. Now these ratios, you're going to be using hypotenuse. So what was tangent ratio, by the way? It was opposite over adjacent. So the sine ratio is going to use hypotenuse. As you can see in this picture, could we use tangent ratios to find either x or y? No. So we're going to show you what a sine ratio is. It's what you may expect it. Just like tangent, you start off with opposite over adjacent. Well, it says, yeah, you're going to be using hypotenuse. So sine ratio, guess what? It's opposite over hypotenuse. This is the sine ratio. Can somebody then guess what the cosine of angle A might be? It's going to be, how about Esther? Over here. What was the cosine? You want to guess? So you already used opposite leg. Exactly. It's the adjacent over the hypotenuse. It's cosine ratio. So if you have a right triangle like this, right? These ratios, they're both over hypotenuse, aren't they? One of them, the sine, is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Okay, so write that down. And we'll see what we could do with these ratios in a minute. So in short, it's nice to abbreviate these things. So in short, sine is what? Opposite over? We just said it. Opposite over? Hypotenuse. So I just wrote down O over H. Is that okay? For opposite, H for hypotenuse. For cosine, what is it? It's going to be adjacent, so A over H. And let's use a tangent too. What's tangent?
A over
Over A. Opposite over adjacent. Okay, so nice way to remember. I think some of you may have heard this. So they just look at the first letters of these things and they go, oh, SOHCAHTOA. That's one of the ways to. Yeah, SOHCAHTOA. So, you know, if you ever forget the ratios, right, anybody see why they do SOHCAHTOA? Sine for opposite over hypotenuse. Cosine starts with C, adjacent over hypotenuse. Tangent, right, is opposite over adjacent. Yeah, so it's a nice way to remember, right, what these ratios. So, okay, so that's.
S in A. What is S in A? Oh, sine in.
Sine of angle A or some angle. Okay.
Sine in.
Right. So this is a nice way to remember, right? These ratios. So let's look at our first example then. Knowing sine, cosine, and tangent ratios, we can find the value of x and y in this right triangle. By the way, could we use tangent for this?
No.
No, because they only give you the hypotenuse, the length of the hypotenuse. So in order to find x or y, we're going to use. Also, could we use Pythagorean theorem on this here?
No.
So they give you an angle measure. Okay. So what can I use to find? Let's look at value of x. What can you do to find the value of x? How about? Anybody see it? How about Austin?
Ooh, pick me. What do you mean how?
So
it could be. Wait. Sine.
Sine is correct. You would use sine to find value of x, right? Why, Austin?
Because it's opposite over adjacent.
That's tangent.
I mean, opposite over hypotenuse.
That's right. So we know the hypotenuse. We don't know the opposite. So sine of what? 67 degrees equals to? X over 120. And do we know how to solve that?
Yeah.
Yeah. And we have the table, right? Remember that table had three values?
Can you draw the triangle? I want to draw
Hold on. And then to find x, what are we going to do to both sides, guys? Multiply both sides by 120. And there is your exact answer. Okay. And of course, you look at your table and look up the value of sine, which is 67 degrees. Which column do we look at? The first one, second, or the third? The first one is the sine. So they looked it up for you. It's 0.9205, and there's the approximated value. And they wanted to write nearest integer, so it's 110. Is that okay? Yeah, in a minute. Yes, question?
So on the test, which one do you write?
So on the test, who can answer that question? I want two answers, exact and approximate. So guess what? You're going to write x equals to 120 times sine of 60.
67 degrees.
Yeah, you will get the table. And then you're gonna write 110.
110.4.
All right. What do we do? Okay, let me show you the table then. Let's look at the value of y. What would you do? What would you do to figure out the value of y on this? How about Andrew?
Oh, can't you add 90 and 67 and subtract that?
Oh, do we need to figure out what this angle is to figure out what the value of y?
No.
You could do it. Actually, you could do it. But we could just do it this way.
67.
Yeah.
67
Yeah. What can we
equals
use to find value of y using the angle 67 degrees, Andrew?
Y over 110.
Right. Y over 120. What's that ratio of? That's the cosine of 67 degrees. Isn't that right? Okay. Of course. How do we get the exact answer for this? In other words, how do we get y by itself here?
Multiply by 1.
Yeah, multiply both sides by 120, and there's your exact answer, right? That's the part that you need to circle for your test, right? And of course, you could look up cosine. Now, which column do we look at? First, second, or yeah, it's the second column. You look at the 67 cosine. It turns out to be 0.3907. You multiply that out, and it's about 47. Okay. So we have found the length of x and y. Okay. Let's take a look at example 2. It says find the value of n. So whenever they ask you for the angle measure like this, what do we need to use? No, when they ask for the angle measure, the other one, it asks for the length of the size, right? When they ask for the angle measure, you know how on the table you got to look backwards? Yeah, you need to use the inverse, right? Do you think we're going to have inverse for, we had inverse for tangent, right? Do you think we have one for sine and cosine? Yeah, it's just looking at backwards, right? Think about it that way. So how are we going to, who can give me the equation for this to find n, first of all? How about, Kevin, what do you think?
It's sine n.
Sine of n degrees equal to?
22 over 40.
How many people agree with Kevin? 22 over 40.
Cosine or sine?
He says sine. Anybody think we should use cosine?
There's no.
What about tangent? Okay, good. So we need to use sine because they have given us the opposite side of this angle and then the hypotenuse, right? So you're right. We need to use sine of 22 over 40, right? Okay, so then what are we going to do next to figure out what n is? Okay, hold on. So there you go. So on your homework tonight, you're going to write this, right? How do we get the n by itself? Well, we got to get rid of this sine, right? You can't really divide by sine because sine isn't some number or anything. It's so, right? It's
idea.
yeah, it's like a ratio of the size. So how do you get rid of this? Well, we've learned this. We multiply both sides by the sine to the negative 1 power, which is sine inverse. We do that to both sides of this, and there's your exact answer. Sine inverse of 22 over 40.
Wait,
Okay? Yes, question?
why don't you do that for the example 1? Why didn't you?
Oh, example 1, because if you go back to example 1, yeah, example 1, are we looking for the actual angle measure or the size here? Size. When you're looking for the size, right, you don't look up backwards on the table. You just, right, you look at the angle measure and then look at what sine is. Sine of that angle is.
So you don't need the inverse.
Yeah, do you remember, like, look, if I wanted to know the sine of 11 degrees, it's right there, 0.1908. You don't go backwards. That's what inverse means. Like inverse, right? They give you the, right? We know what sine of this angle is. So you have to go back and see what angle measure it gives you. Remember that? All right, so there you go. So there's, and then when you divide 22 over 40, so you get 0.55, don't you? So let's look at our table, okay? Let's see which angle. Now you see how we're going backwards. So we have to look at again, first column, second, or the third column. First, we got sine inverse, right? So 0.55. So you see how sine is increasing like this? Where would 0.55 be? Okay, there you go. It's going to be around here somewhere. Anybody see it?
29.
29.
You think it's going to be 29?
0.55?
Yeah, it was 0.55, wasn't it? Look.
Oh, then it's 30 something.
Yeah, 0.55 was the, so 22 over 40 is 0.55, right?
33.
So how many people say it's 33? How many people say it's 34? Which one is closer?
33.
Yes, 33 is closer, isn't it?
Oh, I was looking at
Oh, well, you're looking at the, be careful. That's what I'm telling you guys. Look, right? The first one is the sine. Don't look at the tangent column. Be careful. All right, so look. So it'll be 33. Would you agree?
Yeah.
Because 0.5446 is closer to 0.55 than 0.559, right? Okay, so there you go. And so, whoops. Yeah, so there it is. So that's what you circle,
Right here,
right?
on this-
So you see how I have circled the exact answer?
Yep.
And equals to sine inverse of 22/40. And then that's the other answer that I want you to circle, which is the approximated answer. That's why I have a squiggly line over here, right? It doesn't say equal to, right? Okay, yes?
Does it say 0.55?
Yeah. So if you divide 22/40, you get 0.55, right?
What's the x equals branch?
I'm sorry? Oh, don't worry about that. Okay. Yeah, question?
Do you do the sine to the negative first time?
Because these cancel out like this if you do that.
No, I'm not asking about that. I have to do that. Like, do you just look up the actual, whatever?
Right. This means I want you to. This means, right? Sine inverse of 0.55 means you look at the table, and you look at where 0.55 is, where the closest is, and then you look at the angle measure. That's what you're doing. Does that make sense? You sure? Does this mean to take sine of 0.55 on your? No, it does not mean that. It means look backwards, right? You go to your table. You see this is the closest to 33 degrees, 0.5, right? 46. That's the closest to 0.55, right? So you look at the angle measure. You go backwards, and you ask yourself, which angle gives you that sine of 0.5, right? 5. The closest one is 33 degrees. So this notation is just means look up what angle gives you sine of 0.55. That's what it means. Does that make sense, guys? It doesn't mean take sine of 0.55 again or something. You understand? Okay. We could actually punch this in your calculator. If you're gonna do that, what can we do here? Hit 0.55, right? Then what? Click inverse and click sine. It gives you, yeah, see? It comes to about 33 degrees. That inverse function is really looking up the table the backwards, right? Backward way. Are we okay with that? All right. Here we go. Example 3. I like this problem because this is the kind of problem that you will see on your homework tonight and your test and so forth. An isosceles triangle has sides 8, 8, and 6. It says find the length of its 3 altitudes. So what do they mean by this? Does an isosceles triangle have 3 altitudes, first of all? Yes, it does.
Yeah, any triangle has 3 altitudes.
Exactly. Every triangle has 3 altitudes. Okay, very good. So what kind of, okay, let's draw the obvious one is this. If the sides are 8, 8, and 6, right, here, isn't this the most obvious altitude that you can think of? Right, so this altitude hits the base like this, and then it divides the base, right? So if AB was 6, of course, these are 3 and 3. And the two sides are 8. So it turns out we could actually figure out the altitude of this x. Pretty easy. What can we do to do this? Do we need any of these sine, tangent, or cosine ratio? No, because they're not even giving us any of the angle measure, are they? In order to use sine, cosine, or tangent, right, you need the angle measure, don't you? Here, they just give you these. So who could tell me what to do here? How about Pomon? What do you think?
You know that the other angle. I mean, you find the tangent.
Tangent. Yeah, if you use tangent, then you could figure out the angle measure. But is that what we're looking for? We're looking for the height of this triangle on the right. Pomon, let me give you a hint. Look at this right triangle like this, okay? If you have a right triangle, Pomon, right, and this is 8, this is 3, do you know how to find the third side? Yeah, you do. If you have a right triangle and you know 2 of the sides, you could always figure out the third side using the Pythagorean theorem, right? Guys, don't think too hard, right? You could use the Pythagorean theorem, right, Pomon? So when you do, you simply get square root of 55, which is the exact answer. And approximately, when you punch this into your calculator, it's about 7.4. Is that okay? So we got 1. But is that all they wanted? No, they want the other altitudes. Well, what would the other altitudes look like? How about, so we found one of them, that's great. Yechan, what would the other altitude look like? Oh, that's right. Sorry. John, what would the other altitude look like?
It's 8 to the middle of CB.
Yeah, is it middle of CB? No.
Perpendicular.
Yeah, perpendicular. It's got to be a segment from A to a perpendicular segment from A to CB, right? That's the altitude, like this. Or B to AC, same way. But guess what? Those two altitudes have the same length, don't they? Because it's an isosceles triangle. So we don't have to find both of these. Just find one of them. Here's a picture of it. So A to the side of CB, right?
You don't need to find it.
Oh, we do need to find this, right? But we don't need to find the other one because they have the same length. Because you have an isosceles triangle, right? B to the length of AC, right? The perpendicular segment is the same as this length. Oh, that's a good question. Where did I get 68 degrees? It's not given.
You did the tangent.
We actually have to figure this angle out because otherwise there's no way for us to figure out what y is. Right, guys? Because, you know, imagine that we didn't know that this was 68 degrees, right? Then you only have this one side. Can you use Pythagorean theorem there? Can you use any? You can't use any of these, right? But we know this is 68 degrees. We have to figure this out. So let's take a look at how we do this, okay? Hold on. So take a look at this. I redrew this, okay? So I just drew the one on the right, okay? So let's try to figure out what angle B is. How are we going to figure out what angle B is? Knowing that this is 8, this is 3. I don't want to use x right now. I don't want to use as whoops. I don't want to use 7.4. How come I don't want to use 7.4 as x?
Because it's a common side.
No.
It's
Yes,
the accurate.
Raise your hand. Oh, not raise your. How about? Why would I now use Samantha? How come I don't want to use 7.4 as x?
Because it's an approximation.
It's an approximation, right? You always want to avoid the approximation if you can. Sometimes you can. Okay. Sometimes you have to.
I know.
But if you can, you should always avoid approximation. And actually, you know what? I could have used square root of 55 if I wanted, because that's exact, right? But, well, I know the 8 and 3. Why not use the simpler numbers, correct? So knowing that this is 8 and this is 3, and again, you could have used that as square root of 55. That's fine. But you don't want to use 7.4. How would you find the angle of B? How about, Yvette? What would you do? Okay, let me help you. We know that this 8 is the hypotenuse, right? We know that 3 is the adjacent side of this angle B. So do you know anything about the adjacent and the hypotenuse of a right triangle? Yeah, it's what? Yeah, 3 over 8 is equal to what? Which ratio does it describe? Adjacent over hypotenuse. Cosine of angle B. Isn't that what we get? Now, if I have this equation, we know now how to solve. All you have to do is, to get the angle measure, we need to take?
By 3 by 8. No.
Yeah, so you need to divide by 8. But then how do you get the B by itself? How do you get rid of the cosine? You can't really divide by cosine. It's not some number. Yeah, you take the cosine inverse, exactly. Right? And when you take cosine inverse of 3/8, by the way, what's 3/8? Does anybody have a calculator? What is 3 divided by 8?
It's 12.6.
Okay, so it's 0.375. Let's look at our table. Let's go to our table. And which column do we look at? Be careful, guys. Second one. So notice cosine, it decreases, right? The value. So we want 0.3, right? 0.3. Where's that about? 68. Yeah, there you go. 68. See, we gotta look at the second column. 0.3746, right? That's the closest one, isn't that? Right? So do you see how they got? Oops. Do you see how they got 68 degrees there?
Yeah.
You could just skip all that.
No, you need this 68 degrees. Because if you don't have that, let's go back to our problem.
Then we can't.
Yeah, you can't figure out.
Why?
Yeah, you can't figure out what y is.
Why is 100%?
Right?
All of that, right?
I'm sorry?
The book skipped all of that.
Yeah, the book. Yeah, well, they have it right here. That's what they mean by this. This whole thing. Yes.
Yeah, to show all that work, can you like do it in your head?
Yeah, I wanted you to show work. All right, so now this is 68 degrees. Now do we know how to find y?
Yes.
Okay, who can help me? How about Nicole? How would you find y? Now that we have figured out that angle B is 68 degrees, okay, we know this is 6. By the way, what is this 6? Is this the hypotenuse of this right triangle or the leg? In this small right triangle. Look at the small right triangle. It's the hypotenuse. And we were looking for the y is the what?
Opposite.
Opposite side of the 68 degrees in this small right triangle, right? So which ratio would you like to use? We know the opposite and the hypotenuse. Sine. So we need to know, use the sine of 68 degrees is what? Y over? Correct. Does that make sense?
Okay.
But I have a question. How come there they put squiggly line over here. Isn't this exact?
No, because it's
Yeah, the 68 degrees, we were able to get that 68 degrees by using the approximation. Do you see why it's, right? Okay, so now let's look at what y is. Well, to get the y, you multiply both sides by 6. And of course, sine of 68, you can look it up on the table. Which column are you going to look at? First, second, or third? First. And so when you multiply out, you get about 5.6.
Wait, so you don't need to multiply with the inverse because it's actually
Right.
side,
This
right?
time it's asking for the length of the sides. You don't need the inverse. Only time you need the inverse function is when you're looking for the angle measure, right? Using sine, cosine, or tangent. Any other question? Okay. Does this make sense? So this is the one of the hypotenuse is about 7.4. The other two, right? Because you get the one from B, right? It's both 5.6, correct? Because it's an isosceles triangle. Those two altitudes will be same. Any question?
No.
Very good.
Oh, go on.
Okay. I'll wait. Hold on. So now I'm going to show you some fun facts about this sine, cosine, and tangent. You ready? There are two fun facts about this. It's not that hard to understand. That's why, and it kind of goes really well with these definition of sine, cosine, and tangent. SOHCAHTOA. So fun fact 1. Turns out that
Did you write it?
yes, because you know, like on the finals and like those state tests, they like to give you these. So I want to go over it. Fun fact 1, if you divide sine of an angle over cosine of an angle, okay, so if you have sine over A over cosine of A, this equals to tangent of A, you're right. Yeah. Why? Very good. So I'm going to show you why. This is fun fact 1. If you have sine over A over cosine of A, okay, actually, you know what? I'm going to give you about a minute. Go ahead. I bet you guys could figure this out yourself. Go ahead, everybody try it. Okay, think about it. Fun fact 1. Okay, who could help me how to figure this out? How about Michael? Why would this come out to tangent of that angle?
Because if you do SOHCAHTOA,
Right?
it's
What's sine?
sin is OH.
It's not sin, it's sine. Okay, sine is what?
OH.
Uh-huh.
Cos is
Cosine.
cosine
Uh-huh.
is AH. If you put it over each other, the H's cancel out and then it's OH.
That's right. Look, sine of some angle A over cosine of the same angle, you get opposite over hypotenuse all over adjacent over hypotenuse, right? Do you know how to simplify this fraction?
Yes.
Yeah, all you have to do is multiply both sides, top and bottom by H, right? What happens then? You get O over A, which means
Opposite over adjacent.
that's a tangent of that angle. Okay? Is that okay?
Oh,
Let me show you the second fun fact now. Okay. You ready for fun fact 2?
no.
Here we go.
Wait.
Oh.
Yeah, okay, you need more time? Oh, hold on. Okay, let me go. Fun fact 2. You ready for fun fact 2? Here we go. It says, if you were to square sine of an angle plus cosine of the same angle, oh, thank you. Sine of an angle square plus cosine of the same angle square, it equals to, no, it equals to 1.
Oh.
Yeah, some of you tried it in the calculator, right? It comes out. By the way, sometimes they don't write it this way. They don't like to use parentheses on these, so they write it this way. It's the same thing. So instead of, if you don't want to use the parentheses, the square is next to sine. It doesn't mean you just square the sine only. It's the whole thing is square. Okay. Anyway, yeah, A is some angle. A is some angle. So it could be sine of 30 degrees square plus cosine of 30 degrees. It'll get you 1 every time. Okay. And so of course we have a right triangle. Okay. Why is this true? Let's do this together. First of all, what's sine of an angle? A, for example, here. O over H. Would you not agree? So if you were to square that, what do you get? O square over H square. What about cosine? A over H square. So is this what you get? And so isn't that same as A square over H square? It's kind of nice when you add them together. We have a common denominator of H square.
So it's O squared plus
So you get O square plus A square over H square.
over A.
But how does that become 1? Some of you see it? Okay. Oh, some of you see it. Well, I want you to discuss with your group. Go ahead. I'll wait. Go ahead. Think about it. All right.
Common denominator.
So, Josh, why do you think? What did you guys come up with? Your group. Oh, Oh, let me help you, Josh. Okay, let me help you group now. Everybody pay attention. Look at this right triangle, Josh. Right? What do you know about right triangle? We know that in right triangle, what do you know about the hypotenuse square? That equals to what? Yeah, so isn't h squared equals to a squared plus o squared? So look, what is o squared plus a squared? H squared. So what's h squared? What's h squared over h squared? 1. Do you see that? So that's why if you were to square sine of an angle plus cosine of the same angle squared, it gives you 1. Is that okay? Are we good? Any questions? So this is good to know, okay? All right. No, not quite. Hold on. So here's a fact 2. Sine squared sine a squared plus cosine a squared is equals to 1. Yeah. So now this time I want you to do some. Hold on. Let's review really quickly on this 30, 60, 90 degrees triangle. We know that the ratio of this 30, 60, 90 is what? 1 to rad 3 to 2, right? I could do 1x to rad 3x to 2, but it really x is going to cancel out. Can you then write down sine of 30, cosine of 30, tangent of 30? Sine of 60, cosine of 60, tangent of 60? Go ahead. Let's see if we really got this. Let's review. Go ahead. Write it down. I'll wait for you. Okay, go ahead. For sine of 30 degrees, how many people got half? Right? And cosine of 30, cosine of 30 is rad 3 over 2. Tangent is rad 3 over 3, right? For sine of 60, you gotta tilt your head a little bit, right? What's the opposite side of 60 degrees? Rad 3, right? So rad 3 over 2 is sine of 60. Cosine is what?
Why is it rad 3 over rad?
What?
Why is it right there?
Because
Rad 30, cosine rad.
because cosine of 30 is adjacent over hypotenuse. Here's adjacent. Cosine of 60, yeah, okay, cosine of 60, 1 over 2, and tangent is rad 3. How many people got all these right? Very good. Any questions? Okay, have a great day, guys. Thank you.